F-sharp, pronounced F-sharp, is a general-purpose, high-level, strongly typed, multi-paradigm programming language that encompasses functional, imperative, and object-oriented programming methods. It is most often used as a cross-platform common language infrastructure, CLI language on net, but can also generate JavaScript and graphics processing unit, GPU code. F-sharp is developed by the F-sharp Software Foundation, Microsoft, and open contributors. An open-source, cross-platform compiler for F-sharp is available from the F-sharp Software Foundation. F-sharp is a fully supported language in Visual Studio and JetBrains Writer. Plugins supporting F-sharp exist for many widely used editors including Visual Studio Code, Vim, and Emacs. F-sharp is a member of the ML language family and originated as a .NET framework implementation of a core of the programming language OCaml. It has also been influenced by C#, Python, Haskell, Scala, and Erlang. F-sharp uses an open development and engineering process. The language evolution process is managed by Don Syme from Microsoft Research as the Benevolent Dictator for Life, BDFL, for the language design, together with the F-sharp Software Foundation. Earlier versions of the F-sharp language were designed by Microsoft and Microsoft Research using a closed development process. F-sharp was first included in Visual Studio in the 2010 edition, at the same level as Visual Basic, .NET, and C#, albeit as an option, and remains in all later editions, thus making the language widely available and well-supported. F-sharp originates from Microsoft Research, Cambridge, UK. The language was originally designed and implemented by Don Syme, according to whom in the F-sharp team, they say the F is for fun. Andrew Kennedy contributed to the design of units of measure. The visual F-sharp tools for Visual Studio are developed by Microsoft. The F-sharp Software Foundation developed the F-sharp open-source compiler and tools, incorporating the open-source compiler implementation provided by the Microsoft Visual F-sharp tools team. F-sharp is a strongly typed functional-first language with a large number of capabilities that are normally found only in functional programming languages, while supporting object-oriented features available in C#. Together, these features allow F-sharp programs to be written in a completely functional style and also allow functional and object-oriented styles to be mixed. Examples of functional features are: F-sharp is an expression-based language using eager evaluation and also in some instances lazy evaluation. Every statement in F-sharp, including if expressions, try expressions, and loops, is a composable expression with a static type. Functions and expressions that do not return any value have a return type of unit. F-sharp uses the let keyword for binding values to a name. For example, binds the value 7 to the name x. New types are defined using the type keyword. For functional programming, F-sharp provides tuple, record, discriminated union, list, option, and result types. A tuple represents a set of n values, where n0, the value n, is called the arity of the tuple. A 3-tuple would be represented as a, b, c, where a, b, and c are values of possibly different types. A tuple can be used to store values only when the number of values is known at design time and stays constant during execution. A record is a type where the data members are named. Here is an example of record definition. Records can be created as letter equals name equals AB, age equals 42. The with keyword is used to create a copy of a record, as an R with name equals CD, which creates a new record by copying R and changing the value of the name field, assuming the record created in the last example was named R. A discriminated union type is a type-safe version of C unions. For example, values of the union type can correspond to either union case. The types of the values carried by each union case is included in the definition of each case. The list type is an immutable linked list represented either using a head, tail notation, smiley face, is the cons operator, or a shorthand as item 1, item 2, item 3, an empty list is written. The option type is a discriminated union type with choices some, x, or none. F-sharp types may be generic, implemented as generic .NET types. F-sharp supports lambda functions and closures. All functions in F-sharp are first-class values and are immutable. Functions can be curried being first-class values. Functions can be passed as arguments to other functions. Like other functional programming languages, F-sharp allows function composition using the AND operators. F-sharp provides sequence expressions that define a sequence seq, a, list, or array, through code that generates values. For example, forms a sequence of squares of numbers from 0 to 14 by filtering out numbers from the range of numbers from 0 to 25. Sequences are generators. Values are generated on demand, i.e., are lazily evaluated, while lists and arrays are evaluated eagerly. F# uses pattern matching to bind values to names. Pattern matching is also used when accessing discriminated unions. The union is value matched against pattern rules, and a rule is selected when a match succeeds. F# also supports active patterns as a form of extensible pattern matching. It is used, for example, when multiple ways of matching on a type exist. F# supports a general syntax for defining compositional computations called computation expressions. Sequence expressions, asynchronous computations, and queries are particular kinds of computation expressions. Computation expressions are an implementation of the monad pattern. F# support for imperative programming includes values, and record fields can also be labeled as mutable, for example. Also, F# supports access to all CLI types and objects such as those defined in the system. Collections. Generic namespace defining imperative data structures like other common language infrastructure, CLI languages. F# can use CLI types through object-oriented programming. F# support for object-oriented programming in expressions includes support for object-oriented programming in patterns includes F# object type definitions can be class, struct, interface, enum, or delegate type definitions, corresponding to the definition forms found in C#. For example, here is a class with a constructor taking a name and age, and declaring two properties. F# supports asynchronous programming through asynchronous workflows. An asynchronous workflow is defined as a sequence of commands inside an async, as in the let, indicates that the expression on the right, getting the response, should be done asynchronously, but the flow should only continue when the result is available. In other words, from the point of view of the code block, it's as if getting the response is a blocking call, whereas from the point of view of the system, the thread won't be blocked and may be used to process other flows until the result needed for this one becomes available. The async block may be invoked using the async run synchronously function. Multiple async blocks can be executed in parallel using the async parallel function that takes a list of async objects. In the example, async task is an async object, and creates another async object to run the tasks in the lists in parallel. The resultant object is invoked using async.run synchronously. Inversion of control in F# follows this pattern since version 6.0. F# supports creating, consuming, and returning .NET tasks directly. Parallel programming is supported partly through the async, parallel, async, start, and other operations that run asynchronous blocks in parallel. Parallel programming is also supported through the array. Parallel functional programming operators in the F# standard library, direct use of the system. Threading. Tasks task programming model, the direct use of net thread pool and .NET threads, and through dynamic translation of F# code to alternative parallel execution engines such as GPU code. The F# type system supports units of measure checking for numbers. In F# you can assign units of measure such as meters or kilograms to floating point, and signed integer values. This allows the compiler to check that arithmetic involving these values is dimensionally consistent, helping to prevent common programming mistakes by ensuring that, for instance, lengths aren't mistakenly added to times. The units of measure feature integrates with F# type inference to require minimal type annotations in user code. The F# static type checker provides this functionality at compile time, but units are erased from the compiled code. Consequently, it is not possible to determine a values unit at runtime. F# allows some forms of syntax customizing via metaprogramming to support embedding custom domain-specific languages within the F# language, particularly through computation expressions. F# includes a feature for runtime metaprogramming called quotations. A quotation expression evaluates to an abstract syntax tree representation of the F# expressions. Similarly, definitions labeled with the reflected definition attribute can also be accessed in their quotation form. F# quotations are used for various purposes, including to compile F# code into JavaScript and GPU code. Quotations represent their F# code expressions as data for use by other parts of the program while requiring it to be syntactically correct. F# code F3.0 introduced a form of compile-time metaprogramming through statically extensible type generation called F# type providers. F# type providers allow the F# compiler and tools to be extended with components that provide type information to the compiler on demand at compile time. F# type providers have been used to give strongly typed access to connected information sources in a scalable way, including to the Freebase knowledge graph in F number 3. 0. The F# quotation and computation expression features are combined to implement LINQ queries, for example. The combination of type providers, queries, and strongly typed functional programming is known as information-rich programming. F# supports a variation of the actor programming model through the in-memory implementation of lightweight asynchronous agents, for example. The following code defines an agent and posts two messages. F# is a general-purpose programming language. The Safe Stack is an end-to-end F# stack to develop web applications. It uses ASP.NET Core on the server side and Fable on the client side. Alternative end-to-end F# options include the WebSharper framework and the Oxbecker framework. F# can be used together with the Visual Studio tools for Xamarin to develop apps for iOS and Android. The Fabulous library provides a more comfortable functional interface. Among others, F# is used for quantitative finance programming, energy trading and portfolio optimization, machine learning, business intelligence, and social gaming. On Facebook in the 2010s, F# has been positioned as an optimized alternative to C#. F#'s scripting ability and interlanguage compatibility with all Microsoft products have made it popular among developers. F# can be used as a scripting language, mainly for desktop redevelopment loop, REPL, scripting. The F# open source community includes the F# Software Foundation and the F# open source group at GitHub. Popular open source F# projects include F# features a legacy ML compatibility mode that can directly compile programs written in a large subset of OCaml roughly, with no functors, objects, polymorphic variants, or other additions. A few small samples follow. A record type definition: records are immutable by default and are compared by structural equality. A person class with a constructor taking a name and age and two immutable properties. A simple example that is often used to demonstrate the syntax of functional languages is the factorial function for non-negative 32-bit integers, here shown in F#. Iteration examples, Fibonacci examples, a sample Windows Forms program, asynchronous parallel programming sample, parallel CPU and I/O tasks.